Hi, you guys. This is BC Unit 1, Notes number 2. This one's going to be called Partial Fractions, um, which will lead into a bigger concept that you'll see next time called logistic growth. Okay? So, in terms of the section, you could call it 7.5 logistic growth, or you could really, if it makes it easier for you, you could just call it partial fractions. Okay? So, here's your FLT. Go ahead and pause it and then play whenever you're ready here, okay? Given an integral, students will be able to identify how and when to apply the concept of partial fractions. So the key part here is we need to know not only the how, but also when to apply it, okay? So this is another technique with integration. So let's recap before we get into the actual concept. When we're dealing with integration, in your mind, you're going through this list, okay? So you're hoping that you have simple integrals that are already set up for you, where you just have to find the antiderivative, right? So something like maybe the integral of just sine x. It's something that's straightforward. It doesn't require any other manipulation, okay? Now, if it's not simple, you resort to U-substitution. But remember, how do you know when to use U-substitution? If you look back at your last notes, we're looking for a composition, or as you guys like to call it, a function in a function. Now again, this is used very loosely. So I want to say usually, but not always. There are some cases where it's not always the function in a function, okay? You might have seen that in the last homework assignment. There were a couple problems where it didn't always look like a function in a function, okay? Now, if you don't have a function, you might resort to our next one here, which is called integration by parts. Okay, some people call it ultraviolet voodoo. If it's the right setup, you could use the tabular method, but how do you know when to use integration by parts? Usually when you have a product, when you have two functions multiplied together, okay? Now, what if you don't have any of those? So this is your last resort here, okay? This is called partial fractions. Okay? Now, in general, and I say usually again, not always, usually when you have a fraction. Okay? Usually, not always, so don't take that too literally, okay? So here we go. Partial fractions was a concept that you're supposed to learn in either pre-cal or integrated math 3 honors, right? But partial fractions tend to get cut off the list only because some teachers think that students may not see BC for a very long time, so they save it for me to teach everything, which is awesome. But here we go. So before we get into partial fractions, we're going to review a little bit here, okay? So here we'll start off with part A. Again, play when you're ready. The integral of 1 over x plus 1 dx. So if you guys remember, the integral of 1 over x, and I'll do it on the side here, is actually a simple integral. That is just the natural log of whatever you have at the bottom, x plus c, okay? Now here, there's actually a function x plus 1 inside of that 1 over x function here, okay? But if you guys remember mental U-substitution, you just take, well, I know it's 1 over x, so that's going to be natural log of whatever's at the bottom. Now, if you recall from last year, or I talked about in the previous lesson, x plus 1 is a simple linear. So if you take the derivative of x plus 1, it's really just 1, and the reciprocal of 1 is just 1. So you could do 1 over 1 out here, but it's really redundant. You really don't need it. So we'll just leave that blank. And as always, don't forget your plus c. Okay, hopefully that rings a bell. Let's do a couple more. Now over here is the same idea. 1 over something linear, you know, is going to be a natural log of the absolute value of whatever's on the inside plus the c. But if you look at what's on the inside here, the derivative of 4 minus x, think about what that comes out to, right? The derivative of 4 minus x is just negative 1. And then we take the reciprocal of our derivative. So if the derivative is negative 1, the reciprocal of negative 1 is still negative 1. Okay? And I'll put negative 1 over 1 just to make it look a little bit easier, okay? Let's keep going. Here's part C. Again, it's 1 over something linear, okay? 1 over something linear, so we know it's going to be the natural log of the absolute value of whatever's at the bottom plus the c. But if we take a look at that linear, okay, if we take the derivative of 2x plus 1, we'll get 2. And the reciprocal of 2 is 1/2. So that 1/2 is going to go in the front. Okay. Let's do one more. I think one more ought to do it. Okay. Here's part D. Go ahead and write that down. The integral of 1 over 1/5 x minus 6 dx. Okay. So again, we have 1 over something linear. Okay. So we know it's going to come out to a natural log of the absolute value of whatever's on the inside. Okay, don't forget our plus c because it's indefinite. And the only thing left to question is what goes here, right? So, take a look at what we highlighted. Okay, think about your derivative. Then take its reciprocal. The derivative is 1/5. The reciprocal of 1/5 is just 5. Okay. Now, we went over 4 different examples here, okay? If you still need more, let me know, okay? I'll be live in the lesson, okay? So whenever it's 1 over something linear, you know you're going to get the natural log of whatever that linear is. The only thing in question is what goes out here, right? So whenever you have 1 over something linear, it's pretty easy to integrate. And that's the sole basis of today's concept, okay? We know that if we can make it look like 1 over something linear, we know how to integrate it. So we use that technique. And that technique is called partial fractions, okay? So another review here for you guys. Go ahead and write this down. 1 over x plus 3 plus 1 over x plus 5. You might have seen this way back in integrated math, maybe 1 or 2, or maybe even in algebra 1, okay? Depending on what you took. So if I ask you guys to add these two fractions, right? How do we add fractions? So we add fractions by making sure we have the same denominator, okay? So here we don't have the same denominator, so what we do is we're going to have to get common denominators. So over here I have x plus 3 factor, and over here I have x plus 5 factor. So in order to get the same denominator, I would have to multiply this fraction by an x plus 5 at the top and the bottom to keep it unchanged. And over here, let me get rid of this equal sign. Over here, I'll have to multiply by x plus 3 at the top and the bottom to keep it unchanged. Okay, so our common denominator right now is going to be x plus 5 times x plus 3, or the other way around, it doesn't matter, okay? So at the very top here, I'll highlight it. I have x plus 5 times a 1, so if I distribute that, I'll end up just getting x plus 5. And then I have my plus sign here, plus. And over here, if I distribute that 1 to the x plus 3, that's pretty easy to do. That's just x plus 3. So this ends up being, if I combine like terms here, okay, so we're going back to kind of algebra 1, so the basics, okay? We'll get 2x plus the 8 all over x plus 5 times x plus 3, okay? So that was how you guys add or subtract two different fractions, right? You have to get common denominators. So here's what we're looking at. Let me make some space here. We started off with this in red. Okay, we started off with this in red right here, and then we ended up with this. They're both equivalent statements, meaning they're equal, right? So what I'm going to do here is I am actually going to write that it's equal to 2x plus 8 all over x plus 5, x plus 3. Okay? Okay, that's what we did back in Algebra 1 or IM 1, right? And don't worry if you forgot. That's why I'm teaching you guys. So what if I had all this right? What if I gave you this and I ask you to give me, so give me the partial fractions. So partial fractions is pretty much the reverse process. How do I go back to make it look like the sum or difference of two different fractions again? Okay, now before I show you that idea, okay, on the back of your mind, think about why we would ever want to do this, right? So for now, learn the process, but in the back of your mind, think about, well, why is this helpful with what we're learning today? Okay, so here's what you guys do. Now, obviously, you know what the two partial fractions look like because I gave it to you guys at the very beginning and I asked you guys to get this one here, right? But let's say I just gave you the final answer. How do you go back to what it started with, right? So here's what you do. First step is you want to make sure that the denominator is completely factored. In this case, it already is, okay? Sometimes it won't be. It might look like x squared plus 8x plus 15, and you might have to factor it first, okay? But in this case, it's already factored. So what we're going to do is we're going to transfer those factors over like this, okay? Now, the order really doesn't matter, but I like to go in the same order as it's presented on over here. So if x plus 5 appears first, I'm writing it first over here, okay? So the thing is, we don't know what's on top, right? Assuming that we didn't start off with that answer, okay? So what we do is we're going to create some placeholders. We're gonna just go down the alphabet. We'll call it A, and then the next one will be B, and if we have more, we'll call it C and D and E and F. But really, it's really just A and B, okay? So here's what you do. You now have this equation. Your job is to figure out what A and B come out to. You're solving for A and B, which is kind of weird because you have so many different variables, but there's a way to think about this one here, okay? So when you're given this equation here, what you want to do is you want to go ahead and get rid of all of your fractions, your denominators, to make it a little bit easier, okay? So I'll show you guys. I'll write out the work and then I'll show you the trick, okay? So what I have to do to get rid of all of my denominators is I have to multiply every fraction by x plus 5 times x plus 3. And again, I'm not changing the value of the problem because I'm balancing it, right? I'm multiplying it to every single term. So what happens here is, starting with the left side of the equal sign, the x plus 5s will reduce as well as the x plus 3. So if you notice, there are no more denominators here. So you're just left with 2x plus 8. Okay? I'll bring down my equal sign. Now, over here, the only thing that reduces is the x plus 5, but you're left with the a as well as the x plus 3. Okay, we have a little plus sign right there. Now over here, x plus 3 reduces, but we are left with the b as well as the x plus 5. Okay, so if you notice, we got rid of all of our fractions, which makes this a lot easier to deal with. Okay, now, do I expect you guys to do that every single time? Not at all. Okay, so here's how I would do it. And again, you can do that if it makes more sense to you, but think about it this way. Your denominators will always share the same factors, okay? So what I do is I will just bring down my numerator because I know my denominators will get canceled out. So you mentally do this. Down here, I know x plus 5 is going to go away, so x plus 3 is going to be left with the a. And over here, I know x plus 3 is going to go away, so the other one that's left will be the x plus 5. That's how I do it. It saves you a lot of time and energy there, okay? But I'll leave it up to you guys on how you want to proceed, okay? So here, there's a logistical way, a very logical way of doing it, but it takes a very long time, okay? And then there's the shortcut, and I'll show you guys how to do that. So some people say it's impossible to solve for 3 variables when you're only given one equation. Okay, so here, there's actually a technique that you can do. So what you do is, in your mind, you want to let x equals something. Okay, so here's your job. If you want to solve for b, what's the easiest x value you can put in to make the a go away? So if you wanted to let a disappear, x would have to be what? Right? So if you've given it enough time, if you let x be -3, down in here, that whole thing will go to 0, and if you multiply a with 0, that whole thing is going to disappear. Okay? So you're thinking of x values that'll make it go to 0. Okay? So if we let x be -3, we know that this will disappear. Over here will be just 2 times -3 plus the 8. And over here will just be b times -3 plus 5. So if you look at everything in green, there's only one missing variable, and that's b now. Okay? So let's do that one more time. If we let x be -3, we're going to get 2 times -3 plus 8, okay, which comes out to +2 equals. This middle part disappears because you're multiplying by 0. And over here, if you plug in -3, you should get 2b. Pause, make sure you guys understood what just happened there, okay? Okay, now here, you could just solve for b. b will come out to 1 if you divide by 2 on both sides. So now we know that b is 1. Okay, so now you do the same thing. Well, what if I wanted to get rid of b? What should I let x equal? Okay, play when you're ready. X should definitely be -5 here because -5 plus the 5 will give you 0, and that'll make b go away. Okay, now if x is -5, then the left side should be 2 times -5 plus the 8. And then the middle here, it should be a times -5 plus the 3. And over here, we know it's already 0, so we won't write that down. So that means the left side now will be 2 times -5, which is -10, plus 8, which is -2. Okay? Down in the middle, a times negative 5 plus 3 will just be negative 2a. Okay? And b disappears because you let x equal negative 5. Okay? So what you're going to do is you're just going to divide negative 2 on both sides. A comes out to 1 here. Coincidentally, okay? It's not always the same. Actually, it's rarely the same. So now that we know what a and b are, a will go back here and b will go back here. Make sure you guys put it back in the same spot, okay? So 2x plus 8 all over x plus 5 times x plus 3 comes out to 1 over x plus 5 plus 1 over x plus 3. This is called partial fraction decomposition. When you decompose something, you break it down, okay? So that's the idea of it. So before we move on, think about this, right? Why is this technique so useful? So I want you to think about this here. If I slapped on an integration symbol here, out of these two, and I'll highlight them, out of this orange highlight right here, or its equivalent statement, this green highlight right here, which one is easier to integrate, right? So I'm hoping you guys would say the second one here because it's just a bunch of 1 over something linear. And we just had practice with that right here. When it's ever 1 over something linear and we're integrating, we can do it pretty well, or at least I hope, okay? So that's the beauty of this technique, because you're making something that looks very complicated look a little bit easier to integrate, okay? We won't actually integrate that, but we'll do that in this problem right here. So in example 1, there's a lot of verbiage here. All I want you guys to write down is the integral of x minus 13 all over 2x squared minus 7x plus 3. And then you slap on a dx, okay? Play when you're ready. Okay, so we go through our list, okay? This is definitely not something that's simple. There's definitely no function inside of a function, so U-substitution would not work. There's definitely not a product here, so we're not going to use integration by parts. So we resort to partial fractions, okay? And obviously this looks like a fraction, so you want to use that, okay? So what we want to do is we want to rewrite this so that it looks easier. So separately, what we're going to do is, let me go erase this so we have more space. We want to go ahead and make sure that the denominator is factored. Okay, go ahead and factor the denominator there. Okay, so you should get 2x and an x, right? Both should be minus, minus, and then 1 and a 3. Okay, hopefully you got the same thing, and if you're not sure how you got it, please let me know. So take a look, our denominator is completely factored. Great. So we are going to decompose this, partial fraction decomposition. So because there are 2 factors in the denominator, we're going to set up 2 different fractions, okay? Going in the same order as how you wrote it. Okay, and at the very top, we'll just allocate an A and a B. Okay, I want you guys to keep in mind, just a side note, you don't have to write this part down. If on the left side you wrote x minus 3 and then 2x minus 1, your right side would look like x minus 3 and then 2x minus 1, right? And then you guys would put an A and a B. Now, if you're comparing your answers with your peers, your A and your B's may be different, but your final answer, whatever A is here, it's associated with this x minus 3. So whatever the answer is here should be the same answer here with the x minus 3. So your A and your B's may be flipped, but your final answer should always be the same. I hope that made sense. Okay, so here we go. Okay, Okay, so we made partial fractions. Let's get rid of our denominators. Play when you're ready to check your answer, okay? Okay, so if we multiply by the least common multiple, we should get x minus 13 left over here. We should be left with a a times the x minus 3 factor plus a b times a 2x minus 1 factor. Okay, make sure you guys got that before you move on. Okay, so this is where we get rid of a and b separately, okay? So if I wanted to get rid of a, I should let x equal what? Okay, play when you're ready. A, if I want to get rid of it, x should be 3. So if x is 3, the left-hand side will be 3 minus 13, which is negative 10. The right side, remember a disappears, so b times 2 times 3 minus 1, that'll give me 5b. And that's enough for me to solve and find out that b comes out to negative 2. So we know b is negative 2. Okay. Over here, what should I let x equal if I want to get rid of b? Now this one's not super obvious, but just think about it. If I want that to go to 0, in my mind, if I want it to go to 0, x should be 1/2. Okay, so you're going to put 1/2 here. So if x is 1/2, on the left side, you'll have, I'll write it on the side here, 1/2 minus 13. Okay, 1/2 minus 13 is just the same thing as 1/2 minus 26 over 2. And if you don't see that, all I did was I multiplied the top and bottom by 2. All right. So on the left side will be negative 25 over 2. It does get a little messy, but nothing that you guys can't handle, okay? I know the b term will go away because we made it go to 0. And over here, we're going to have a times 1/2 minus 3. Think about what that all comes out to in here. Get common denominators. You should get negative 5 over 2a. Okay, so two ways that you could solve for a here. You could divide by negative 5 over 2, or you can multiply by the reciprocal. I'm going to multiply by 2 over negative 5 so that they cancel out. I'll multiply by 2 over negative 5 here. A, if you reduce it to its core, you should get 5. Okay, the 2's reduce out. Negative 25 divided by negative 5 should give you a positive 5 here, okay? Okay, so that's where the grunt work comes in, okay? So now that we got that out of the way, we know that A will be 5 and that B is negative 2, okay? Now, don't erase your work. I just don't have a lot of space here, okay? So now that we know that these two statements are equal, when we integrate this, it's a lot easier, okay? So first thing you do is the number at the top, whatever it is, you can bump it outside. So this is just 5 times the integral over 2x minus 1 dx. Okay, and then we have that plus sign right here. Plus, that negative 2 can pop out, and we'll be left with 1 over x minus 3 dx. Okay, so now what we've done is we've created integrals that were easier to integrate because it's just 1 over something linear. So here we go. We have a 5 and we have a negative 2 here. I'll just bring that down right away. This right here, play when you're ready, but think about what that integral comes out to. We practiced earlier, so feel free to go back if you need to. Okay, so it's 1 over something linear, so I know the integral of that is going to be some type of natural log of the same linear. Okay, but if I take a look at that linear, the derivative is 2. The reciprocal of 2 is 1/2. Okay? Now over here, it's 1 over something linear. So I know it's going to be the natural log of the same linear. Okay? And then I take a look at this linear here. It's a simple linear, so the derivative of x minus 3 is just 1, and the reciprocal is just 1, so we won't need to worry about that, okay? And then, as always, plus the c. This is messy, but you just leave it alone, okay? So obviously, doing this for the first time, it's going to take a lot of thought, okay? But you guys will find out where you can cut your corners. Finding out your partial fraction decomposition will be a lot faster, okay? But let me know if you have questions before you move on, okay? Here's part B. All I want you to write down is the integral of 1 over x squared minus 5x plus 6 dx, okay? Pause, go as far as you can, and then play when you're ready here, okay? All right, so I know that down below, that'll be x minus 3 times x minus 2. Some of you may have written it the other way around, but it doesn't matter. So before I integrate this, I know I can't integrate it simply. There's no U-substitution here. There's definitely no product for integration by parts. So I know I have to use partial fractions, okay? This is the same thing as something over x minus 3 plus something over x minus 2. If I get rid of my denominators, I'm going to be left with 1 equals a times x minus 2 plus b times x minus 3. Okay? If I let x equal 2, my equation will be 1 equals negative b. So b will be negative 1. And if I let x equal 3 here, I'll have the equation 1 equals a. So I have my a and my b. So my a is 1 and my b is negative 1. Okay, so if I integrate that, that's the same thing as the integral of 1 over x minus 3. Now that 1 you could bring on the outside, but it's just a 1, so it doesn't do anything. Dx minus, and it's the minus because I just brought that out there, minus 1, you know, I'll put the 1s in there just so I don't confuse you guys, over x minus 2 dx. The integral of that is just going to be the natural log of the absolute value of x minus 3. There's really no coefficient that's going to go on the outside because the derivative of x minus 3 is just 1, and the reciprocal of 1 is just 1 here, okay? Same thing over here. So you're just going to be left with the natural log of the absolute value of x minus 3 minus the natural log of the absolute value of x minus 2. Don't forget your plus c, and that's it. Okay? Now, suppose you were to make think about multiple choice questions, right? This is just something to keep in the back of your mind. Here can be rewritten. If you guys remember log properties, it's just one other like annoying thing that you kind of have to recall. But remember that we can condense logs. Minus implies division. Plus the c. Addition implies multiplication, but we'll get there when we get there. I kind of just wanted to plant that seed right there, okay? Here's one for you guys to try, part C. Play when you're ready. Okay, this is x plus 5 all over x plus 2, x minus 1. That's going to be a over x plus 2 plus b over x minus 1. Okay, so then I'll have x plus 5, a times x minus 1 plus b times x plus 2. Okay, if I let x equal 1, I will have 6 equals 3b. If I let x equal 1. Okay, so that means b comes out to 2. If I let x equal -2, okay, and that means on the left side I'll get 3 equals -3a. So that means a comes out to -1. Now moving pretty quickly, but again, pause and play wherever you're ready, okay? So -1 is right here, +2 is right there. Now, I was saying before, if you guys wrote x minus 1 first and then x plus 2, it shouldn't matter as long as the correct numbers are with the same factor, okay? Okay, so if we integrate that, you should get -1 natural log of x plus 2 plus 2 natural log of x minus 1 plus the c. We won't worry about writing that, rewriting that out, okay? But if you got that, great. If you're watching it over and over and you still don't get it, text me right away, okay? Okay, here are some released AP questions, okay? This is something that you may see, so definitely try it on your own here and play when you're ready. Okay, so I know right away this is going to be a over 2x minus 3 plus b over x plus 2. Now remember, when it's a multiple choice question, you don't have to write every single step, so I'm kind of just going through my stream of consciousness. That's what they call it. So if I multiply everything out there, I should get 7x equals a times x plus 2 plus b times 2x minus 3. If I let x equals -2, I will get -14 equals -7b. So that tells me that b is going to be 2. Okay, so right away, I want you guys to understand what I'm thinking here. If b is 2, that's going to be 2 over x plus 2. And if I integrate that, I know I'm going to get 2 natural log of x plus 2. So I know it can't be this one because of that minus sign. I know it's definitely not D or E because there's no way that you would integrate that and get that, right? So you're left with really just A and B here. So let's keep going. If I let x equal 3/2, okay, that B will go to 0. So on the left side, I should get 21 over 2 equals 3/2 plus 2, that's 4 over 2, so you should get 7 over 2 here. Okay, if I multiply by the reciprocal, a should come out to 3 positive. Okay, so 3 here, if I integrate 3 over 2x minus 3, now, remember, that 3 will pop out to the outside. I know I'm going to get a natural log of the same linear, but check out that linear, okay? The derivative of that is going to be 2. The reciprocal of 2 is going to be 1/2. Okay, so on the outside, you're really getting a 3 over 2, so I know the better answer is going to be A here, okay? Now, don't expect to move this fast, okay? If you're moving this fast, great, but I'm doing it just for the sake of the shortness of the video, okay? But replay this as much as you guys need to, okay? Here's another one. Play when you're ready. So that's 2x over x plus 1, x plus 2 equals a over x plus 1 plus b over x plus 2. If I multiply everything out, I should get 2x equals a x plus 2 plus b x plus 1. If I let x equal -2, I'll get -4 equals -b. So b comes out to 4. Okay, so right away, if I know that b is 4 and I integrate that, I should get 4 natural log of x plus 2. Let's skim through this here. It's not going to be A because A doesn't even have that 4. It's not going to be B. C has a negative 4. That's not going to be it either. Oh, there you go. So the only one that's really possible is D here. Okay? So you didn't even have to finish the whole thing, and you got your answer, right? So definitely keep strategy in mind when you're dealing with multiple choice questions, okay? Okay, so we haven't dealt with this one here. This will be the last one for the day. But notice how there's a definite integral there. Okay? We handle it the same way. So pause and then play when you're ready, okay? So we'll have 3 over x minus 1, x plus 2, equal a over x minus 1, plus b over x plus 2. So if I multiply that out, I should get 3 equals a times x plus 2 plus b times x minus 1. If I let x equal negative 2, the a goes away, so I should get 3 equals negative 3b. So b comes out to negative 1. So right there, b is negative 1. Okay? If I let x equal 1, I'll get 3 equals 3a. So a comes out to 1. Okay, so let's integrate that there. So the integral of 1 over x minus 1 plus negative 1 x plus 2 dx. That should give me the natural log of x minus 1 minus the natural log of x plus 2. And we're going from 2 to 3. So you do have to do a little bit of work here. So when you plug in your upper minus your lower, your upper should be the natural log of 3 minus 1, which is 2, minus the natural log of 3 plus 2, which is 5. Okay, minus, then you plug in your lower. That's the natural log of 2 minus 1, which is 1, minus the natural log of 2 plus 2, which is 4. Okay, so if you clean this up a bit, you should get this. So natural log of 1, you guys have to remember, goes to 0. So we have the natural log of 2 minus the natural log of 5 minus the natural log of 4. Okay? Notice how that's none of your answers, or at least visibly. Okay? So you got to remember that minus implies division. So that's the natural log of 2 divided by 5 divided by 4. Okay? Or natural log of 2 divided by 5 times the reciprocal. Wait, is that right? What am I missing? Let's double check our work here. What did I miss? Oh, right here. I'm sorry. Let me backtrack. So I did not see that there was a negative here. So a negative times a negative is a positive. Hopefully you caught that. So here we go. So that's the natural log of 2 divided by the 5 times the 4. Okay. Now we multiply because it's addition, and we divide because there was a minus sign here, okay? A little bit of review back in your previous courses, but nothing that you guys can't just refresh on. So this comes out to the natural log of 8 over 5, okay? So this problem took a little bit of time. Again, you're not going to get good at this unless you keep practicing, okay? So before we conclude, let's recap, okay? Given an integral, you'll be able to identify how and when to apply the concept of partial fractions. So when do you know how to apply it, right? So hopefully you know when is when you have fractions generally, right? How do you do it? partial fraction decomposition. And hopefully you guys had enough practice with that, okay? Make sure that you scan your notes into a PDF, submit it for points, and then start on your homework right away. I'll be there to help you guys too, okay? Thanks.